Now, in this series, we are going to look at continuity of a function. Okay. Now, look at this number one. They said, discuss the continuity of the function below. F of s is equal to. Now, this is a piecewise function. Okay. This is a piecewise function. That is, it contains more than one function inside of it. This is a function containing this at this given condition. It has this at this given condition. So, look at this one, number two. Okay, at what point, if n is the following function not continuous, this is x minus 3 at this condition, s squared plus 1 at this condition, s cubed plus 4 at this condition. Okay, so now, what is the deal, or what is continuity all about? Continuity is like a chain, making things to be hooked together. So now, what I'm going to do is this. They say discuss the continuity of the function below. So the function is f of x. Now this f of s is this at this condition, and this f of s is also this at this condition. So as you can see, f of s is minus 1 over 5 at s equal to 2. And they say that f of s is this at s not equal to 2. So for this function to be continuous, I will force this one to take that 2 they said it should not take. Now, if I give it 2 and it is able to produce minus 1 over 5, exactly the same thing, that is, if I force this one that they said cannot take 2, if I force it to take 2 and it produces minus 1 over 5, it means the function is continuous. But if it does not produce minus 1 over 5, it means that the function is discontinuous. So a discontinuous function is not continuous. So look at what I'm going to do now. I will bring out this 2 minus x over this. So I'll bring out 2 minus x over x squared plus x minus 6. So I will force it to take this 2, because when this one takes 2, it is 1 minus 1 of 5. So I'll force this one to also take 2 to see if it will be the same thing as this. So the first thing I'm going to do is this. Anytime you see this type of thing, now you are seeing something like a quadratic function at the below. Try factorizing it first before you start taking your limit, because see, I'm taking limits as s goes to 2. So you take the limit of this as s goes to 2 to see whether it will give you this. So first thing first, whenever you're taking limits and you're seeing a quadratic function or a cubic, the first thing you do is that you factorize it first to see if it can eliminate whatever thing you have up. So don't forget how to factorize it with your calculator. I want to factorize s squared plus x minus 6. So my a is 1, my b is 1, and my c is minus 6. So I'll go to this mode. I will choose equation 5. I will choose 3. So my a is 1, my b is 1, my c is minus 6. So my x1 is 2, then my x2 is minus 3. So it means if I factorize x squared plus x minus 6, I will get x to be 2, and I will get x to be minus 3. So this is something as a x, if this comes over minus 2, now for this one, if this comes over plus 3. So it means x minus 2 times x plus 3 will give rise to this. Okay, so I'll carry it and come here. So I have limits as s goes to 2. So this is something as a 2 minus x over x minus 2 and x plus 3. So if you check this and this, they look alike. The difference is that this is 2 minus x and this is s minus 2. So let me multiply up and down by minus minus. Minus and minus will still be plus. So I'm doing this so that one of them will look like the other. So this will now be like limits as s goes to 2. So minus entering here now will give me minus times 2 will give me minus 2. Minus times minus s will give me plus s. So it is now x minus 2 over, now minus is here, x minus 2 and x plus what? 3. Such a way that this can eliminate this. So what I have now is limit as s goes to what? 2 of 1 over minus into x plus what? 3. When this goes to this, we have 1. So this is gone. Minus this. So now, taking the limit as s goes to 2, I'll get 1 over minus into 2 plus 3, which will give me 1 over 2 plus 3 is 5. 5 times minus 1 will give us minus what? 5. So as you can see, it gave us minus 1 over what? 5. So it means that the function is continuous at s equal to what? 2. So that's why this is the correct option. So for number 2, we're going to do the same thing. At what point, if n is the following function not continuous? At what point, if n is the function not continuous? So the function can be continuous at this point if this one and this one will give the same answer at minus 1. And also, it will be continuous at 2 if and only if this one and this one will give the same answer at what? 2. Exactly what we did here. As you can see, this one at 2 gave the same answer as this one at 2. So it means if you check this one, like here we have 1, 2, 3, 3 functions. And this one now, what this one and this one has in common, the number they have in common is minus 1, minus 1. and the number this one and this one has in common is 2 and 2. So this one and this one should give the same value at -1, and again this one and this one should give the same value at what? 2. So when that thing happens, we say that the function is what? Continuous. So let us find the value of this at -1. So this is s minus 3. So s minus 3 at -1, so we're taking limits as s goes to -1. So this will give us what? -1 minus 3, which will give us minus what? 4. So let us find the limit of this one as s goes to -1. So limit as s goes to -1 of the function x squared plus 1. So this will now be what? -1 raised to power 2 plus 1. -1 to 2 will give us 1 plus what? 1. So this one will give us what? 2. So as you can see, this and this are not what? Equal. So it is not continuous at -1. It is not continuous at x equal to -1. Remember, the question said at what point, if any, is the following function not continuous? So at -1 it is not continuous because -4 and 2 are not what? Equal. The answer this one gave us at -1 and the answer this one gave us as -1, they are not the same thing. So let us test for 2, 2. Now for this one, when this one at point 2, so let us take the limit as s goes to 2 of x squared plus 1. So this will give us 2 raised to power 2 plus 1, which will give us 4 plus 1, which is what? 5. Let us take this one. Let us test this one at 2. So this is limit as s goes to 2 of s cubed plus 4. So this will give us 2 to 3 plus 4. 2 raised to power 3 is 8. 8 plus 2 will give us what? 12. As you can see, this one is 5, this one is 12. Both of them are not equal. Okay, 12 is not equal to 5. So at -1, this function gave us -4. At -1, this function gave us what? 2. And -4 and 2 are not equal. Okay, so it is not satisfying Pestyn-Lehmann theorem. Okay, now looking at this one, at 2 this one gave us 5, and at 2 this one gave us what? 12. They are not equal. So remember that at -1 we tested for this and this because they have -1 in common. So it means both of them should have the same value at -1, and again this one and this one has 2 in common. It means that both of them should have the same value in common for it to be what? Continuous. But at -1, this one gave another thing. At -1, this one gave another thing. So both of them are not continuous at -1. Again, this one and this one has 2 and 2 in common. Now at 2, this one gave another thing. At 2, this one gave another thing. So on that note, the function is not continuous at point -1 and what? 2. So the correct option here is option what? A. So at -1, it is not continuous. At 2, it is also not continuous. So look at number 3. At what point is the function continuous? Now, if you check this one and this one, both of them have 1 in common. And if you check this one and this one, both of them have 5 in common. So for this function to be continuous, this one at 1 should give the same answer at this one as well. So if at 1, this one is still 1, this one is like is constant, it's a constant function. So this one still remains 1. So what it entails is that since both of them have 1 in common in the form of interval, at point 1, this one should also be 1. And again, this one and this one has 5 and 5 in common. It means at point 5, this one should give the same result as this. So let us start with this one. Let's start with the first one. So let us go for limits as s goes to what? 1. So we're taking limit as because both this and this, they have 1 in common. So 2x minus 1. So this will now be 2 brackets. Our s is what? 1 minus 1. 2 times 1 is 2. 2 minus 1 will give us what? 1. So as you can see, 1 is the same thing as what? 1. So both of them have the same result at this. Okay, so the function is continuous at point 1. So now again, let us check if the function is continuous at 5. So at 5, this one is also 1. Now let us check the value of this one at 5. So let us check the limit of the second one. The limit as s goes to what? 5 of this function, 5x minus what? 24. So this will now give us what? 5 bracket 5 minus what? 24. 5 times 5 is 25 minus 24, which will still give us what? 1. Now as you can see, this one also gave us 1 at point what? 5. So what does that entail? The function is what? Continuous at both 1 and what? 5. So at 1, this one gave the same thing as this, and at 5, this one gave the same result as this. So the function is continuous at point 1 and at point what? 5. So option B is the correct answer. So go to past questions, pick up questions under continuity and solve. Okay.